That'd be silly. I want to get the snowplows a chance to like plow the road, right?
Yeah,
Which did not happen, right? Once I got to 30, it was fine, but everything else, oh god, right? No one asked you, Jerica. No one asked. No one. Literally no one. Okay? All right. Turn the page. It does smell weird in here. All right, cool. So we are given that angle 7 is 85 degrees, and angle 10 is 115. So angle 10 is 115, and they give us angle 7 is 85. Cool. So find all the angles, right? I'm not going to answer these. I'm just going to look at the diagram and figure stuff out. So check it out. 10 and 14, are they the same or are they not? Why aren't they? Because P and Q aren't parallel. So check it out. I have a line, a transversal cutting two parallels, right? So 2 and 10 are going to be the same, right? But are 10 and 14 going to be the same? No, because I don't have a line cutting two parallels. P and Q aren't parallel, are they? So that's not going to be the same. Do you see it? Wonderful. So if 2 and 10 are the same, that means 4 and 12 are also the same by vertical angles, right? That means 1 and 3 must be the same, and 9 and 11, too soon, must be the same. If I wanted to figure out what angle 9 was, what would I have to do? Yeah, 180 minus 115, right? So 5 to get to 20. So we're at 120, and then 60 more to get to 180. So that's 65, right? And I think from there you can figure out the rest of those. Yes, ma'am?
How did you get angle 9?
I got angle 9 because I know they're a linear pair, which means they're supplementary, right?
How did you get angle 10?
Angle 10 was given to us in the directions.
Then I must be on the wrong page.
We're on page 2.
That makes sense.
Staple crew a little bit behind, right? Okay. So, Jenna, these both add up to 180 because they're a linear pair, right?
Yeah.
So I did 180 minus 115 in my head. 65, trust me. Okay. Same thing down here, Jenna. This is 85. So I know that this angle right here is going to be supplementary with it. And if that's 85, then this has to be 95. Because 95 plus 5 is 100, and 80 plus 100 is 180. These guys are going to be the same because of vertical. These are corresponding, right? So I think you can figure out from there what all the other angles are. That answers all these. Questions on that? Again, the key is to figure out which ones are the same. These won't be, even though they're both in the top right corners, because those aren't both parallel. So what I would do if I was you is if you wanted to figure out if two angles were the same, cover up everything except for those two intersections, right? And ask yourself, do I have two parallels cut by a transversal? Answer is no, so they're not going to be the same. Are those going to be the same? Yes, because I have two parallels cut by a transversal. You dig? If you look at it all at once, it's kind of intimidating. You all right, Taylor? Okay. So yes, you just couldn't see? Okay, because you said no. I just couldn't see. Are you okay? No. All right. Oh, yep. Well, of course. This only happens for your hour. Guys, donate. All right. I hate snow. I absolutely hate snow. Next one. 11. Next page. We're on page 3 now. Number 11 says, find the measure of each angle. So, first off, we know that we have two sets of parallel lines here, so that's convenient. That means that everything here and here is going to be the same because, look, two parallel lines cut by a transversal, yeah? We also know over here, two parallel lines cut by a transversal, so 1 and 5 are the same, aren't they? Now, look at the bottom two. Do we have two parallel lines cut by a transversal? We do, don't we? All right, so 13 is also going to be congruent. Now, by vertical angles, we get 3, 11, 15, and 7. And that means that 2, 6, 4, 8, 12, 10, 14, and 16 are all the same. That's the beauty of having two sets of parallel lines. So what do we know about these two expressions right here? 3y plus 10 and 8y minus 50. What do we know about them?
They're equal.
They're equal. So if I write them, 3y plus 10 equals 8y minus 50, we can solve for y. Do you need me to solve for y, or can you do it on your own? Add 50, subtract 3y. Y equals 12. If y is 12, we can find the measure of each angle by plugging it in, right? I added 50. I subtracted 3y. I divided by 5. I got 12. Trust me on the arithmetic, okay? If y is 12, then the next step is to plug it in to figure out the angle measures, right? 3 times 12, trust me, 36. Add 10, 46 degrees. Which means all the red angles are 46. The blue angle then is going to be 180 minus 46. 180 minus 40 is 140. Subtract 6, we get 134.
Wait, did you get 46 because you plugged in 3 plus, or times 12 plus 10?
Mm-hmm. Mm-hmm. Number 12, solve for each variable. We have two parallel lines cut by another. So we have transversals. That means the top and the top are going to be the same, right? Which means by vertical, these are the same. Now, while it's true that 9x plus 12 equals 4y minus 10, is that going to be helpful? No, because one equation, two variables, right? Doesn't work. But we do know that these are going to be congruent as well, right? So this right here is 3x. So what does that tell us about these two expressions? They're not equal, but they are a linear pair, which means they add up to what? 180. You smell what I'm stepping in? You guys starting to remember this? So that means they add up to be 180. So now we're at 12x plus 12 equals 180. We subtract 12. We get 168. We divide, and I believe we get, what is it, 9, 10, 10, 48, 4, 14. So now we have x equals 14, which means this angle down here is 3 times 14. That's going to be 42. So that's 42 right there. What is the relationship between 3y minus 10 and 42? They're linear pairs, so they add up to 180. And now I can solve for y. I'm going to subtract 42 and add 10. So that's 158. Am I wrong about that? 190, 90 minus 40, 50, 148. $37. Trust me on the algebra, okay? Right now I just want to make sure you see how to do it. Do you understand what's going on here and why I'm doing it that way? Do you see why those equal 180? Okay. Do you see why these being equal is true but not helpful? Okay. How are we feeling? Not so bad, right? Turn the page. Extend these guys out. Extend this guy. Beautiful. Glorious. That looks amazing. This angle right here and this angle right here are the same by cap, right? Do you see it? So that's 5x minus 20. There are multiple ways to do this. These angles are the same by vertical, right? So what does that tell us about 5x minus 20 and 3x? They equal each other. And we can solve that, right? So we get 20 equals 2x. Subtract the 3x, add the 20 over, which means x equals 10. Let's plug that in. That means this is 30 degrees, right? And this is 50 minus 20, which is also 30, because they're all congruent, right? How you feeling? So this is 30. That's 2y, that's 4y. Do you see the triangle? Internal angles of a triangle always add up to. So we know that 2y plus 4y plus 30 is going to get us 180, right? So that means 6y equals 150. And y is 25. Again, trying to get x set up so I got it. And once I have that, I can say, look, all those add up to 180, and I can solve. How do you feel? Okay. Again, it's seeing where the transversal is and trying to figure out which angles are congruent, and then figuring out how you want to solve it. The way I saw it, I saw those two are the same, those two are the same, let's go get it, right? Different ways to do it. 14, this is where we have to draw that auxiliary line, right? And we say it's parallel to the others. That tells us that the blue part of x and the green part of x will add together, right, to make regular x. If you cover up the bottom, notice that these guys are corresponding, right? I think it's easier to see if you cover it up. And these are vertical, right? So what's this blue part of x going to equal? 62. And if I cover the top part up, I know that this bit here, 144, is going to be supplementary with this bit here. And the reason I'm talking about that bit is because that bit, if I extend this out, will be the same as this. You dig? Right? Those angles are going to be the same. 144 is supplementary with this angle, so I add 6 to get to 150, 30 more to get to 180. So if this is 36, so is the green by vertical. So x in total is going to be both these added up, which is 98. Like that boy band from the 90s. 98 degrees. What is slope? What is slope? The rise over the run. It's also the change in y over the change in x, because that's what that means, right? And we know that it's going to be vertical distance over the change in x, meaning the horizontal distance, right? Subtraction is distance. Y's are vertical. X's are horizontal. Done. Again, what is slope? It's rise over run. You know that. The rise is how much we've gone up, right? The change vertically. Run is how much we've changed horizontally. What does that look like? Well, vertical distance, horizontal distance. If you know what it means, it's not hard. That's the beauty. If you don't know what it means, it's going to be very hard. So let me help you. How do you feel? That's it. That's it. Turn the page. We're going to do one on this page. Again, I just gave you lots of examples. We're trying to figure out whether these lines would be parallel or perpendicular. It's what we did the other day. Okay? Okay? I give you 2 points. How do we find the slope? How much we changed vertically, right? If I'm on -2 and I move to -1, what did I do? I went up 1. That's my rise. If I'm on 0 and I move to -2, what did I do? I moved left 2, in other words, -2. So there's our slope. If you don't like how that looks, you can write it like this, right? Slope of line 2. -3 moving to -4. I went down 1, right? -1 going to -3. I went down 2. 2 negatives make a positive, and we're here. So, what did I do? I did slope formula, right? That's what we were talking about on the last page, this thing. Now, you might have done it differently because I was thinking about how much I moved. I was really thinking about the change, right? If you did subtraction, you might have got the signs flipped. You might have got a -1 up top and a +2 in the bottom. That's okay. It's the same dumb crap, right? As long as there's one negative sign here. Maybe you got no negative signs there. That's fine. 2 negatives make a positive, right? Just a different way of thinking about it. Just be consistent in how you do it. I started here, -2 going to -1. I went down 1. Or I'm sorry, I went up 1, right? -2 to -1 is up 1. 0 to -2, I went -2. Going from -3 to -4, well, that's -1 to get there. -1 to -3, I subtracted 2 to get from here to here. Again, going in this direction. -1 going to -3, it's a -2. So here are our slopes. First of all, are these 2 lines going to be parallel? No, because they'd have to be the same. Are they the same? No, they're different, right? One's a negative. Are they perpendicular? How do we know if they're perpendicular? Flip and negate. They're negated, but are they flipped? So it's neither.
So it's a skew.
I'm sorry?
It's a skew.
A skew. I'll accept neither or a skew. That's fine. I know I changed the directions from the homework.
So, what, like, if you put it into, like, the formula, like, -2
Mhm.
minus, like, it's...
It means they just intersect randomly. It's neither.
Never mind. I found it.
Yeah. Good question, yeah.
So how do you know if it's parallel with the
Well, parallel, we know the slopes are going to equal each other, right? Shelby, does that make sense? And then we know for perpendicular, the slopes are flips and negates of each other. And since it's neither of those, it's going to be a skew. A skew just means they intersect at some random angle, right? If they're not parallel, they're going to intersect at some point. How? Some random angle, right? That's all of those. I just gave you lots of examples. Turn the page. I want a line that's parallel to this and goes through this point. If they're parallel, the lines are going to have the same slope. So our line is going to have y equals 3/4 x as well, plus b. This is the homework, right? How do I figure out b? I plug in -4 and 6 for x and y. And then I solve, right? So let's do that. Remember, multiplying fractions works this way. You can either time divide by the bottom first. Which one do you want to do? I'm going to divide by the bottom. What's -4 divided by 4? -1 times by the top now. -3. Add 3, we get 9 equals b. So if 9 equals b, our equation is y equals 3/4 x. And that b we just found out is positive 9, right? Now we're going to graph that line. Here's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we go up 3 over 4. 1, 2, 3, 4. We could also go down 3, back 4, right? Same thing. Draw our line. Try not to miss the dots like I did. So I went up to 9, the y-intercept, right? And then I use my slope. How you feel? If you're not sure, oh, did I get that right? Graph this guy too. See if they do look parallel. They should if they have the same slope. That's it. Yes, ma'am.
How did you get -3?
-3. -4 divided by 4 is -1. Times 3 is -3. Yep. Again, I know no one's taught you how to do fraction multiplication like that, but man, I wish they did. Let's look at number 23 just real quick. It says parallel to x equals 5. If you want, graph x equals 5. Here's where x is equal to 5. Right here. All the points where x is 5. That's this, right? So if we want a line that's parallel to x equals 5 and goes through -7, 6, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6. Doesn't it have to be vertical? Okay. Every point on that line has something in common. It's where x equals what? On this line, the red one. The red one, all the x's are -7. Do you guys see that? All the x's are going to be -7. So that's it. Again, if you know what it means, it can be easy. If you don't know what it means, it's like, oh God, what do I do, right? All of the points on this line have -7 for their x value. Smell what I'm stepping in? Turn the page. Look at number 25. We want perpendicular. Perpendicular slope is flip and negate, right? So our equation is going to be the flip of a third. A third flipped is what? 3. Change the sign so it's positive. Solve for b. Do I need to show more? I think you know how to graph. I think you know how to plug it in and solve, right? That's it. Ready to move on? Again, 27 and 28, we have y equals 8 for 27, and they want it perpendicular to that. Here's where y equals 8. Y-axis, 1, 2, 3, 4, 5, 6, 7, 6. Where y equals 6. Thank you. That's what I said. Insolent heathens. Scumbags. I'll translate. So y equals 6. So if we want it perpendicular, what's this line going to look like? It has to be what? If it's perpendicular, we want it to be like this, right? So this line that goes through 0, 0 has to be vertical, right? To be perpendicular. All the points on that line have something in common.
0.
Which one? X or y is always 0? X is always 0. See how y can change vertically, right? So x equals 0 is the line that's perpendicular to that. These can be really easy if you know what you're doing. Or they can be awful. I want to put these on there because they're fast, they're easy, and they're important. Don't screw it up. Okay?
So for 28 would be y equals 0 then?
Yeah, if you want a perpendicular, right? Maybe not 0, y equals -1 is what it would be. Because that's the point it has to go through.
Oh, yeah.
Last bit. Find the slope of the line. Remember this from the homework? Find the slope of the line, and then find me a line that's perpendicular or parallel and goes through the point. It's the same thing we were just doing, but they don't give us the slope. We got to figure it out. So we find 2 nice points, and we figure out, oh, look, we're over 3 and up 3. That's a slope of 1, right? Go through the point. I'll see you tomorrow. They said it couldn't be done. They said you couldn't have a paper airplane fight and review in the same day. But that's what the people wanted. That is what the people wanted. And who am I to object? I believe in you, Nolan. To the power of static electricity. Oh, there's a hook there.
Yeah.
Oh, okay.